overcharge your cells, you can have a fire. I don't know if this fire extinguisher is going to do it. It's powder. These are A123 cells I was testing and charging. And again, we went off to have a conversation and kind of forgot to that I had 100 amps going into these batteries for about 30 minutes.
What's that smoke, Jack?
What's this? That is a swollen one.
Let one come flying out of the back here.
Swelled up. Brian had just invested in a fire extinguisher, which I'm very pleased with at the moment.
It worked well. Jesus.
Now that we have the current off of them, a little of that PKP. Some of my cables out of the fray. Life at EVTV.
There's never a dull moment.
It's just a rag.
Ah.
And I had some just kind of stacked there too. That weren't even hooked up. I'm afraid we're going to lose them. This is a document of some sort. Oh, I lost some set of meter leads too. Crops are both germicidal and good at smoking.
And you can stomp out fires.
Yeah. Still flaming. Don't put it on there.
I'm gonna go open up our door over here
Yeah, let's do that.
before we asphyxiate ourselves.
We approximately 7 meter leads. So, A123 cells will indeed go into flames if they're overcharged.
burst into
It's the
flame.
usual thing. Hello, I'm Jack Rickard with EVTV. This is my compadre and consigliore El Breno Noto.
Hey, good to be here.
It is Friday,
It is Friday, actually, yes.
sneaking up on Turkey Bird Day.
I know.
Do you
Love it.
remember as a child a thing on television called Jiffy Pop?
Yes, I do, in fact, the popcorn. Yeah.
You put it on the stove and it'd swell up.
Yeah, and we would kind of poke it and, yeah, come a little aluminum pan.
You know, my dad never would let us get one of those. He said that it worked just as well to put a little oil in a
Bottom of a
in a pan and put the stuff out of the sack, and it was about a fifth the cost.
Yeah, right, a couple of pennies for popcorn.
But you know, you can do the same thing with a $30 A123 cell.
That does look kind of like Jiffy Pop.
It's a little bit like Jiffy Pop.
I take it some heat was applied to that.
Well, I was going to set up an experiment to go with that.
Well, I'd call that an experiment.
Yeah, to celebrate, the Chevy Volt fires and so forth. And we will. Maybe I'll do that next week. I'm actually these lithium metal oxide cells. I don't think are appropriate for automotive use anyway. But these
Yeah.
LiFePO 4 that we use, an A123 is a lithium iron phosphate cell.
Yeah.
They have their own dangers if you overcharge them.
Yes. Yes.
And we did. I set them up. It takes an hour, 45 minutes or something, and I walk off and start doing something else.
Yeah, we made a phone call or something,
Yeah,
I think. And
and it just gets terrible.
I should have worn my "it was on fire when I got here" shirt if I would have known.
Right. Fun at EVTV.
That's EVTV, that's right.
We've actually had 3 or 4 fires this week. When all of I burnt down.
Well, you set some rags on fire
I set
with
some rags
with wax.
on fire with wax.
We had a
Trying
battery
to-
blow up.
Oh, that's right.
We had a
Kind of
Sealed-
impressive. We hooked up a charger backwards to our battery, and it blew the battery up
Blew the
instead of
battery.
the charger. I like that.
That was pretty cool. Yeah, something gave, and
And,
at least it wasn't a charger this
So
time.
we've had an incendiary week.
Yeah, thank God it is Friday.
There's not a whole lot of news out there. Nissan
Yeah.
is going to introduce their Chademo fast charger
Oh, really?
at $9,600, I think.
That's less than they were saying, wasn't it? Earlier it was like
Quite a
15
bit.
grand or more than that.
They were
Yeah.
17,000.
Yeah,
They were going
17.
to have them at Leaf dealerships, which is an interesting play.
Mm-hmm.
And now you can buy one for home for less than $10,000. Might have been $9,900. I think it was $9,600. Like a 400 volt, 300 amp,
Yeah.
level 3
Yeah.
Chademo
Yeah.
charger.
Wow. That's pretty cool.
It is. I haven't gotten the details on this, and it doesn't make any sense to me. It would have to be 3-phase power,
Yeah,
which
who
you're not
has it?
going to have at your house.
No, not unless you want to pay a whole heck of a lot. Yeah, I don't know.
You know what it might be, though, is I've talked about this mother bank, and it would be fairly inexpensive, done with lead acid cells.
Oh, yeah.
It's just a bank of batteries
Uh-huh.
that charge slowly
Right.
all
right.
day long, and then you pull in and plug in your leaf, and it goes.
It just sucks it out. Yeah.
They're working on standards in Europe for this. SAE is still fumbling around.
Yeah.
SAE, you can kind of read that General Motors, not Nissan.
Yeah, true,
Is
true, yeah.
flapping around out there. The Japanese automakers, because of TEPCO's very successful experiment in Tokyo, are kind of on board this Chademo
With the Chademo
standard.
standard, yeah.
And Nissan already has it built in the cars they're selling, and they've sold more cars than the Volt.
And the volt. Yeah, yeah. Okay.
And I think
That's how you get it adopted.
this is a pretty strong play.
Mm-hmm.
If all the Nissan dealers had level 3 charging, and they
Yeah.
made level 3 chargers available to people who wanted them at home or at work, which is not going to be a very big percentage, I can tell you.
Right, right.
$10,000 is still not an attractive notion.
No.
I would have one.
Right,
but,
right. Yeah, we need one.
But most people are not going to want that. But even just several hundred of them out of all
Yeah.
the Leaf owners, this is a powerful stroke on the part of Nissans to say, hey, we've got the fast charge port now.
Right.
And our
In
people
car,
can use it.
and they can use it.
And you don't have that.
Right. Yeah, that's a big play.
And so that's competitively, rather than spin and disassemblement, that's a feature.
Right, right.
And I like competition that causes features
That's right.
and more value for
Yeah,
the money.
absolutely. Oh, that's
So I don't
great.
know quite what to think about that, but I think it's probably means more than you think.
Yeah, yeah.
And it could have some long-term implications for all of us that would be very interesting.
I think so. I think it's a great move for them.
When we're talking about chargers, why don't we go talk about chargers? I have something kind of interesting to show.
Okay, good. Charger talk's always good.
We'll start by talking about charging.
Okay,
Let's do that.
all right.
NetGain Motors, home of the Warp, Transwarp, and Impulse motors, introduced the improved Warp 9 motor. The Warp 9 is a 9 1/4 diameter series wound DC motor with a double-ended shaft featuring 26 improvements for 2010. Externally, the terminal studs have been enlarged from 3/8 to 1/2 inch diameter. Bigger is better. On the inside, a larger commutator, new brush composition, and split brush design with heavier springs handle even higher voltages and currents than before. Our new fan increases airflow by almost 50% over typical paddle-style fans. And all this translates into improved performance. For even more performance or larger applications, take a look at NetGain's Warp 11 motor, an 11 3/4 diameter series wound DC motor for even greater torque and power. Since 2002, NetGain Motors has been leading the EV industry with precision, performance, and price. Visit us at go-ev.com. NetGain Motors, warp power to go.
Before we talk about chargers and charging specifically, let's talk about our battery and how it works. This is always kind of hard to picture. Hard for me to picture. It's called the rocking chair battery. It's because lithium ions, cations, that is a lithium atom that is missing its outer valence band electron, which is easily removed from the atom, is our charge carrier. A lithium ion, properly a cation, a positively charged lithium ion. This material is lithium carbonate, LiPF6 typically, and that is our charge carrier. Here's the part that's a little mystical. It's called intercalation with graphite. This is our anode. We have a copper plate that I've drawn here and a couple of layers of graphite. These are actually sort of graphene sheets, single atom thick sheets of carbon. And they have a crystalline structure. Normally, if you intercalate a lot of different materials, fluorides and so forth, into that structure, what you wind up with is what they call covalent bonds, where the carbon atom and which is the host and the intercalated atom share an external electron. It's called a covalent bond, and it actually becomes part of the crystalline structure. In the case of lithium, this doesn't actually happen. The lithium ion joins this carbon matrix of carbon atoms that are in a crystalline matrix by charge transfer. And this is just not even a representative thing here. Let's put in a lithium atom here and one over here. Between those layers, that lithium atom can be held by charge. The lithium atom is positive, and the carbon atoms have electrons in their outer valence band, and so they're attracted. The lithium takes up its proper position in the matrix, and that is 6 carbon atoms to each lithium ion, and but they do not form covalent bonds. It is simply held in position in this matrix. This actually causes a slight expansion of the carbon crystal structure, and when the lithium ion deintercalates or exits that structure, it decreases in volume, and this breaks up the carbon to some degree and is part of your life of your battery. Intercalate, when it goes into this structure, we call that intercalating, which is an oxidative function. Let's see, oxidation would be like giving up an electron. We're not properly here, and this is not exactly like a fire, but akin to it. And I'd like you to think of batteries not as an electrical device, but as a chemical device. And oxidation you're somewhat familiar with. Rust being a very slow oxidation of steel. A campfire being a rapid oxidation of firewood, and firing a pistol would be a very rapid oxidation of gunpowder. Your battery is between rust and a fire, although in my case sometimes it is a fire, but it's a chemical reaction. And all efforts to model this as an electrical device are doomed, in my mind, to failure. It can be useful in a few instances, but it leads more people astray than it quite does. In any event, if we put enough electrons on this copper plate, it will attract these positive cations of lithium to intercalate into the carbon, where they kind of hold the electrons in position by charge transfer. There is no covalency here. These are simply located in the crystalline structure, and they're a positive. They make the graphite more positive, which is an attraction to the electrons on the copper plate. If we put enough electrons on there, the electrons have a problem. Just like a magnet that you cannot force the poles together, the electrons at a subatomic level have an aversion to each other. They push away from each other. And a high concentration of electrons will always want to go to a low concentration of electrons. On the other side of our battery, we have an aluminum plate with layers of lithium iron phosphate. And so because we have piled a lot of electrons over here, and our lithium has intercalated into our graphite, we have a higher density of electrons here than we have on our aluminum positive plate. It's not positive inherently, it's positive in relationship to this plate. And this plate is negative in relationship to this plate, and they have no absolute values at all. This is only useful relative to each other. Because of this, there is a difference in potential between these two plates, and we call that a voltage. If we have almost all of our lithium ions over here and almost none over here, that voltage potential will be right at 3.40 volts for LiFePO4 cells. And this varies depending on the chemistry of the anode and the cathode. But for a graphite and LiFePO4 cell, it's 3.40 volts. That's its voltage. It will never go above that. If you take it above that, you will destroy the cell, as I'm getting quite good at doing. Because of this difference in potential, if we hook our motor up to this, these electrons want to move over here. And when they do, they have to go through the motor. Now, there's something else that is kind of annoying in the way people describe this. And that is these electrons moving over here through the motor to the plate. They do not. The electrons move at a remarkably slow pace, about 1.5 inches a minute. And that migration of free electrons through conductors like copper that have plenty of spaces and plenty of free electrons, that migration of the electrons themselves is kind of what causes the heat. But if I take an electron off of this and move it off, it's going to bump the next one. And that one's going to bump the next one. And that one's going to bump the next one. Picture a pipe full of marbles. And it's absolutely full of them. If I put a marble in here, one's going to pop out the other end. How long does it take for this marble to transit out here? Well, this marble didn't transit at all. It simply went in, forcing one out, and it happened essentially instantly. And that's why our electron flow is very near the speed of light. The electrons didn't really do this flow, but the charges, as you bring this electron closer to this one, it's repelled. It pushes against this one, just like the marbles in the pipe. But anyway, we have current flow in my world, which is different from Ben Franklin's and different from the way most of you all were taught. A current flow is from negative to positive, the direction of the electron flow. And so we go through the motor, do the work, and show up over here. When we do, this releases some of the tension here. One of our lithium ions can then transit over here. This deintercalates from the graphite portion, goes through our microporous separator, which the lithium ions can easily go through, and it intercalates into the lithium iron phosphate, which is a coating on the aluminum plate. And so it matches up then with an incoming electron. As the electrons equalize, more of them move over here, more lithium ions deintercalate here and go through what we call, as the opposite of the oxidation function, is the redox or reduction function to intercalate with the lithium iron phosphate here. And so our lithium ions migrate to this point, and our electrons through the external circuit migrate to this point until we have a decreasing level of potential or voltage at about 2.5 volts, still negative here and positive here. Our lithium is depleted, or our lithium ions have all moved over. And so we don't want to take it any below that because we don't really have any charge carriers here. And we'll damage the cell in trying to move more electrons over here. These electrons have to be attracted to something, and there's no lithium. So it starts to form plating on our cathode, and that's a no-no. And that causes some problems with the cell. That's the process. Let's add our charger. We're going to take electrons from the positive or cathode, and we're going to physically move them to the negative terminal or the anode of the cell. And we're going to do this with a reverse potential that's higher than the battery potential. And we're going to get a current flow here. You're going to measure a voltage between these two terminals. It's not really the voltage of the cell. It's not really the voltage of the charger. It is a result of the two. And so charging our lithium batteries is we're going to suck electrons off of the cathode, place them on the anode, and cause the lithium cation to again deintercalate from the cathode, move through the separator, and intercalate with the graphite. And when we remove the charger, we'll have, and let that dissipate, surface charge dissipate, we'll be back to 3.4 volts difference in potential, representing the excess of electrons on the anode with reference to the cathode. And you have to hook up both ends to get any power. They only have a difference in potential in reference to each other. And so that's the charge process. All of our lithium ions would be over here. As many electrons as we could get in to match that would be on our cathode. If we remove the charger, we will fall to 3.40 volts. because we typically undercharge it a bit, you'll see us at 3.35 quite often. And as we discharge, and when you get below 3 volts, we're getting to the tail end of the lithium, and it goes very quickly. The charge curve, of course, on a lithium cell looks like this. As we go up in voltage, it goes up slowly until the very end, and then it turns vertical. This is a band from 3.1 to 3.3 volts apparent. Not much changes. And this goes from 3.3 to up here to 4 volts almost instantly. Below 3.1 or 3.0, down to 2.5, which is fully discharged, again, we have this vertical cliff. It's falling off of here. It's going down so fast. This is a characteristic charge curve of this chemistry. And now let's go talk about chargers. Charging is nothing more than hooking up a power supply to a battery and applying a voltage to it to force electrons into the cell. I do this. Normally, you would terminate this by voltage, and we've talked about how that's done. Often here at EVTV, we'll put a battery on a power supply and kind of do it manually. My entire family being somewhat subject to Alzheimer's, I often like to go out in the shop because it takes an hour or two. It's like watching paint dry. It's boring. I like to go out and talk to Brian, maybe work on some other things. And occasionally, actually all too often, I forget about the battery, and I get to terminate the charge process, typically with a fire extinguisher. This week, we were playing with some A123 cells, fascinating devices. This is what an overcharged one looks like. It swells up pretty good. So, you want to use a good chemical fire extinguisher when doing those kind of experiments that put out the powder, not CO2 or water. They simply will not put out these batteries. You have to bury the fire in a chemical retardant powder. That's one way to terminate a charge. And we've talked a lot about the Volt fires, the fires on the Princess of Scandinavia, the Link Volt fire, any number of fires, battery management systems, and charging. The issue is not in charging or the batteries being natively a problem. It's normally they're being overcharged. Now, there are different types of batteries. The lithium metal oxide batteries, lithium cobalt oxide, as used in the Tesla, and lithium manganese oxide, as used in the Leaf and the Volt, do have some thermal issues and can go into flames while operating. Normally, the lithium iron phosphate cells, without some sort of external heat from a bad connection, will not do that in operation, but they can do it when they're overcharged, and that's the most common way to cause a fire, as I've so ably demonstrated on so many occasions. This brings up the topic of chargers for your electric vehicle and what to use to charge them, and unfortunately we have very limited choices. And when you stop and think about it, this makes sense. They're an electrical device. You hook them up to the grid and then to your car, and they cause fires. Who wants to be in that line of business selling a device that can have that kind of liability? Manzanita Micro makes a charger for the EV community specifically, and has done so for a number of years. It started with lead acid, and it kind of remains a little bit crude for our uses. This is an Elcon 4,000 watt charger that we've been using recently. It comes from China. It's kind of hard to sue a company in China over these when you've imported them. And it's actually a pretty good constant current, constant voltage charger. The Manzanita puts out great power. In fact, this one's a 75 watt charger, but it also costs close to $5,000. This is $4,750. This Elcon is a little 4,000 watt jobber, and it'll put out 40 or 50 amps, but it costs more like $1,700. And they have a little 3,000 watt jobber that's $800 or $900. Very good at constant current, constant voltage, but you have to have it configured at the factory for the number of cells you want and the voltage you want to charge to. And you're not really, they'll put up to 10 of these charge curves in here, and you can select from those, but you can't really configure any of them. You can select from the ones they configure. The Brusa charger, we've used in the past, comes from Switzerland. It's quite configurable. You get on a laptop and a little program and change a fairly elaborate set of charge profile variables to get just the charge curve you want, really quite beyond what's needed for a lithium iron phosphate cell. A 3,000 watt version of that is typically $4,000 now. And so the charger is kind of an expensive thing, and it's we don't have much to pick from with regards to chargers. And with the liability involved in charger manufacture, I'm not sure that's going to get better for the hobby EV community unless people within that community address that rather directly. And we're going to talk about that some today. Let's talk a little bit about what's inside these chargers and what they actually do and what the important parts are. For our purposes with lithium-ion cells, the most important part is to be able to measure the voltage at the battery pack and know what that is, and to set a specific voltage where we switch from pumping current into the battery to a process of constant voltage maintenance where we modify our current to maintain that voltage, and then to properly terminate or shut off the charger at the right point to prevent a fire. Let's talk about the components a little. The media has hopelessly confused the charger issue where it's almost impossible to straighten out. When you buy an electric car and they give you a device, it is not a charger. The charger is in the car. What they are referring to as a charger, we call EVSE, or Electric Vehicle Support Equipment, and its function is to provide a very ordinary 240 volts AC power from the grid, from your house, to your car. And that 240 volts AC is the standard power that comes into your house. It comes in to a circuit breaker panel on 2 wires, really 3. One of them is the ground, which is literally sunk into a pole in the ground outside of your house. And you have 2 lines, each of which would measure 120 volts AC compared to ground, but because they're out of phase with each other, they're 240 volts AC. If you look in your electrical panel, you have 2 rows of circuit breakers. And the circuit breakers down this side are on one 120 volt leg, and the circuit breakers on this side are on the other for 120 volts. You may have a big double circuit breaker that's for your dryer or your oven or your stove. And that circuit breaker taps into its own side, but also reaches across to the other, and it provides 2 wires out, and the difference between the two is the sum of 120 or 240 volts AC. And that's what the EVSE that you get is going to use, and provide 240 volts AC to your car. You cannot charge a battery with AC voltage. And let's talk about just an AC waveform, which a lot of you are going to be familiar with. This is kind of boring, but some of you don't really get it. This line is 0 volts. This is a sinusoidal wave at 60 hertz, or 60 times per second. It's going to go to a positive voltage, and then it's going to reverse and go to a negative voltage and come back to 0. And this continues forever, actually. This peak value on this voltage is not 120 or 240 volts AC. It's 1.414 times 240 volts AC, or about 320 volts peak. We state it as the root mean square, kind of like the average, but not the average, the root mean square, a useful value, above an average, but it's useful value by convention, and we call it 240 volts AC RMS properly. If you put this on a battery, which has a positive and a negative terminal, during the positive portion of the waveform, where we're above 0, would you believe it would charge that battery? And it rather doesn't matter how big the battery is or what this voltage is. For a while, it would all work. When it crosses through 0 and goes negative, it would blow the battery up, because we've reversed the polarity of the cell, and that would be very damaging. Let's design a little circuit to convert this AC waveform into something useful. And I'll keep the AC waveform up here, not with that. Where are all my, here's a marker. As a reminder, we use what's called the full wave bridge. Let me see if I can draw this and get it right before the 3rd try. That's pretty close. During one phase, we would go negative in here, positive this way. We use these 2 diodes, and that converts our waveform to a positive wave. During the negative cycle, we would go through these 2 diodes and do the same thing. And so we convert our positive and negative pulse to 2 positive pulses, or 2 positive half waves. And again, the peak value of that is going to be about 320 volts DC. Of course, it varies as this does. So let's put a capacitor across this output, and that will gentle it out somewhat. More like this, and this being our 320 volts DC. Or if we had a 120 instead of 240, this would be about 160 volts DC. In either case, it's all positive, even though it varies. And if we hook that up to our battery, to the positive terminal, and negative to the negative terminal, this being negative, and this being positive, we could charge our battery. And this is actually called a bad boy charger. If you take a rectifier, full wave bridge rectifier, and a cap, and plug it into the wall, you can use that to charge a battery. And in fact, people do. Particularly in the lead acid days, they did this. And you can charge your car with this, even though your car is 120 or 140 volts. You can put the full 320 across there, causes a big current into the batteries, and it'll put energy into the batteries and cause the migration of those lithium ions, and it will charge your battery pack. The problem, of course, is measuring current and voltage and being able to do something with that. And it's kind of uncontrolled. You're hooking up your grid to your battery pack, no isolation, no protection, no fusing, and just letting the wall pump energy into your battery. And that's why it's called a bad boy charger. Let's get rid of all that. This full wave bridge is commonly available now. What did I do with them? I've got a couple of them here. This is on eBay, a 50 amp full wave bridge, and costs about $10. This is a somewhat more advanced 3-phase full wave bridge from Sanrec. This will do about 160 amps, and it might be $40. And that's all you need for a full wave bridge rectifier, a big capacitor, and you have a bad boy charger. And it will work. On September 22nd of 2009, in the DIY Electric Forum, a man named Simon Rafferty, a UK engineer, announced a design for a $200 do-it-yourself buck charger that kind of caught the imagination of the EV community and has grown from there. Let's talk about a buck charger. Let's say I have my bridge rectifier here and a cap. And this is plus 320 volts DC. This is your negative or your return. A buck charging circuit or a buck circuit will convert one voltage to another and regulate the current with a kind of a pretty good efficiency, 90 or 95%. It's not power factor corrected. Let's talk about how it does that. I'm going to put a switch here. I'm going to put another switch here and run that down to our negative. I'm going to draw an inductor here and a capacitor. And I'm going to call this negative. I'm going to call this positive. I'm going to put a honking big diode here in case we hook up a battery backwards or something. just to protect it. This is a basic circuit. If I close this switch, I have current flow to my battery and across this cap and back through this inductor, through this switch to my rectifier. As that current grows, this cap is going to charge in voltage. The lines of magnetic flux build out in this inductor, and it resists a change in current, and this resists a change in voltage. But eventually, we're going to charge up to our 320 volts DC here. I'm then going to open that switch and close this switch. And this is going to invert, and this is going to become a source. As our lines of magnetic flux collapse, this inductor is going to maintain our current flow. And now it's going to go negative to positive this way. And again, we get negative and positive until this has collapsed. And as it collapses, this current and this voltage is going to weaken, and this voltage will start to fall off of this cap. If I open this and close this, it's going to recharge this circuit. And if I alternate between these two things, depending on what percentage of this waveform is on, that I turn on and off, if this is 10% square wave and this is 90% off, then this one would be 90% on and 10% off. Because whenever this one's open, this one's closed. Whenever this one's closed, this one's open, this one's closed. And we're going to switch back and forth between those. What that's going to do is just like our chopper, PWM chopper controller regulates the voltage and current through our motor, we're going to regulate both the current and the voltage here. Now we're not probably going, this is a buck circuit, not a boost circuit. We're probably not going to ever adjust it above 320. But we can, actually it might be a little bit, but not much. But any voltage below that, we can actually control quite precisely at these 2 points by varying this pulse width modulation. And so we need an inductor and 2 switches and a cap, and we can take this rectified voltage. This cap will smooth it quite a bit, so will the inductor actually, and we can fairly precisely control the current and the voltage of our output of our charger. Now, we have to control these 2 switches, and we have to be able to detect what this voltage and current is in order to control them in an able fashion. This is actually an R-Cube Mega. It's a ripoff of the Arduino Mega. Arduino is an open source adaptation of this chip, an Atmel microcontroller. And what they've done is put it on a board and brought all the pins, or virtually all the pins, out to the edge of the card, added a little power supply to run it, and a little serial port so you can talk to it, and have published the spec for doing that, where anybody can make these boards. This was a group in Italy, and they called it the Arduino, And you can get these boards for like 29 bucks. And they have digital inputs and outputs. They have an analog inputs that where you can measure things, and they have a pulse width modulated output. And so if we had an Arduino Mega driving a little circuit to step up the voltage and current to drive these switches, it could be the intelligence running the switches, and we could also hook up a couple of the analog inputs to our output to detect the voltage and current. Most importantly, and why this has caught on in such huge numbers, is they did a tool chain for it where you can program this in C++. Kind of a reduced subset of C++. Actually, most of C++ is in there. But to turn on digital inputs and outputs, measure analog inputs and so forth, they've added a few little special functions to C++ in a simple little editor that you can download and install on your PC and program this via a USB port. And so people are using them for robots and build lights and all sorts of things. But this, it would be an intelligent and programmable controller to run this. Our switches, again, our old friend, the insulated gate bipolar transistor, or IGBT, that we use in the controllers. They happen to make one, and it's called the half bridge. This is a PowerX CM400DU-12F. They're on eBay for 30 or 40 bucks. This one will do 600 volts and 400 amps for that kind of level, and it provides two switches that are connected right here, and so we'll do both parts of the switching part. And so these are some of the components that could be used to do a buck circuit charger. Now, once we have all that, we can charge our batteries quite inexpensively and control quite precisely what voltage and current we apply to them, and we can terminate the charge whenever we want by programming the Arduino. And that's basically what Simon Rafferty, Damien McGuire from Ireland actually joined in this discussion, which went 51 pages, and it became kind of a classic on DIY Electric, how to build a $200 charger that wasn't a bad boy charger, but was actually programmable and configurable to charge lithium-ion cells. And it became so popular, Valery Mitsakov, one of our speakers at the convention, who has the EV Works out in California, doing BMW conversions, I think, has productized this open source design. And he will sell you a kit with all the components to do a 10 kilowatt charger for $849, which is a much more reasonable price. By building your own, nobody is really going on the hook for the liability except you. And you can have a fully configurable, in fact, programmable charger for less than $1,000. He's also going to build these for you if you'd rather, and that's going to cost another $1,000. But for a lot of you, piecing this together, which isn't terribly hard, but it can involve some time, and you do have to solder and pay attention to some things. He will assemble them and sell them for about $1,000 over that. I think about $1,850. We've gotten one from him 3 times. It has had some problems. He's worked most of them out, and it seems to be charging at this point. Let's go take a look.
NetGain Controls introduces the new Warp Drive Industrial Controller. The Industrial is designed to handle a maximum of 1400 amps and up to a 360 volt nominal battery pack. The unit's rugged design looks and works great in the automotive environment while protecting it from the elements. In addition to higher continuous currents than the classic Warp Drive controller, the Industrial comes with several major enhancements. Liquid cooling is available and uses leak-free and rugged AN fittings. The Industrial controller has complete isolation on both throttle channels, giving the highest possible immunity from situations that might affect the electrical throttle input. High voltage connections are fully protected underneath the sealed cover. Voltage leaks between vehicle chassis and a battery pack are detected, alerting the user to potential safety problems. Controller settings can be completely customized using the NetGain Controls interface module, which can also log data to an onboard SD card. The controller weighs in at 25 pounds. Visit www.ngcontrols.com to order your Warp Drive Industrial Controller now.
Okay, this is Valerie Mitzikov's build of Simon Rafferty's open source charger. Valerie's with Electric Motor Works. He's calling this the EMW Smart Charge 10,000. It's a 10 kilowatt intelligent charger. It's $849 for the kit, or $1849 assembled, I believe. Let's talk a little bit about some of the features. This is my output terminal strip. This is not how you would build a charger for professional work with all this on the outside, but this is what he sent me in the third iteration. It's working, but I would put all this inside. This is your output terminals. This is positive and this is negative. Here I've got a AC cord connected with ground in the two phases to 240 volts AC. This is just a terminal board for various things. This is his display and control unit. It provides a little bitty LCD display and two buttons where you can configure this device. This is a cord that he provides that you would hook up to a laptop where you can actually program the Arduino. Now, that's somewhat important. You don't really need to be able to program in C++. They've got this software worked out, but they change it periodically, and you want to be able to, it's kind of analogous to updating the firmware. As they make changes, you want to download them from their device and upload them to the Arduino that's in this box. But the configuration of the charge, anyone can do, and we're going to demonstrate that. It's quite simple. And this is, it's not the way I would do it. You know, we would set the charge voltage switch point, the current level in, and the current level where we would discontinue, and that would be about it. He's tried to make it simple for us and has instead made it a little bit more complicated than all that. Okay, let's flip her on. All right, we get a little display here. We have a few seconds. I'm going to press this, and it's asked me cell type. Now I can change that with my left button between a nickel metal hydride, NiCad, and LiFePO. We want LiFePO. When we get it, the selection we want with the red button, we press the green. Now it asks me a CV cutoff. That's our constant voltage cutoff. It says 350 divided by 100. That would be 3.5 volts per cell. And so he's letting you set your per cell voltage first. Again, with each digit, I have a 3. I can accept that with a green. I have a 5. I can change it with a red or accept with a green. And 0, I'm going to accept with the green. We'll take 3.5 volts. We're using CALB cells in my car here. And we'll accept the whole amount for green. Now it asks me for the number of cells. Again, I have 0 selected. I can, in the first digit, I'll accept that. 5 and 7, I have 57 cells in Speedster Redux. And so we're going to accept all that. And now it asks me for the capacity. It uses capacity to determine the current level where it shuts off. This is an important value. But we're going to put in our 180 amp hours, and it will use 0.05 of that, which is the specification for the Calvin Thunder Sky cells. And so it'll be about 9 amps it will cut off. And so we'll accept that. It tells me now to short the output and press any button. What an odd instruction. What it is doing is zeroing its voltmeter to detect the 0 volts on the output. You'll get a little capacitor pop if you've used this. Right now we haven't. I'm going to press the button, and it says calibrated 0. Now it says connect to the battery to calibrate, so I'm going to unshort that and take this and connect it directly, not to our charger, but directly to the cells. I've got this set up with the famed Anderson fire starter connector. And I've got a voltmeter hooked up here. It says 188.7 volts. It says to measure and enter the actual battery voltage, and it says 180. I'm going to accept the 1 and the 8, but I'm going to change the 0 to 188, which is pretty close, and accept that. It says confirm 57 LiPo 4 cells, 180 amps. I'm going to take that as a yes. And it says press button to change parameters, 6 seconds left. We're going to let this go. And we should start charging. And indeed, we get a screen that gives me duty cycle of 71.9%, 79.1%, a frequency of 20 kilohertz. Now that's 20,000 times a second that we're switching those switches. And an output of 29 amps at 193 volts, temperature's 29C, and the fan starts to increase as this goes because it needs to cool itself to maintain those IGBTs. So I'm going to flip it up this way so we get good current, good airflow through it. And it's blowing a gale out the back. He's really got some fans going here. Now we need to take some measurements, see what this thing's doing. I have it at 193.2 volts with a voltmeter. He thinks it's at 195 volts. I'm gonna say he's erring on the side of caution. That's 1.8 volts, and I kind of like that. He gives it a little bit. He says we're charging. It's jumping around from 23 to 57 amp hours. Let me get a clamp on voltmeter here, or ammeter. See if I zero that out. I'm measuring 37.4 amps. Let's write that down. .4 amperes. I'm actually up to 193.5 on my charge voltage. .193.5 times 37.4 is 7,236.9 watts. That's some wattage. Let's go take a look at our fire chief. Just spin it around and zoom in here, brain. I'm showing 47, 48 amperes at 229 volts going into this device, and that's showing about 8,350 watts. Let's go back and do a little calculation. If I took 7,236.9, divided it by 8,350, I get about an 86.66% efficiency rating. That's not great, but it's not bad. And so we're taking in about 48 amps at 240 volts, putting out 37.4 amps at 193 volts. 38 amps is what it's showing right now. And so this charger is charging quite well at the moment. We can set the power up even higher, but my cables start getting hot. I didn't use a big enough wire, but I think this will do up to the 60 amps or the 10 kilowatts he claims. Let's see if we actually hit that voltage. This episode of EVTV is brought to you by the Winston Battery Company Limited, makers of high-capacity lithium yttrium rare earth cells, including the popular 160 amp-hour model featuring cycle lives in excess of 5,000 cycles when discharged to 70%, the longest useful working life of any available battery of any chemistry. A leading battery technology scientist, inventor, and entrepreneur since 1995, Mr. Winston Chung envisions a new world of clean electric power for the dawn of a new era of electric vehicles. For your next electric vehicle design project, contact Winston Battery Limited. Energy for a bright future. We're feeding our charger off of our Fire Chief gasoline pump, J1772. I've got a little 220 plug here, 240 volts, and I can read what's going into the charger. We're down to 9.4 or 5 amperes, about 1,400 watts at 241 volts. Let's take a look at the charger. That's getting down pretty close to the cutoff. Our car here has been holding steady at 197.8 volts. I think we were supposed to be at about 199 volts on the 3.5 volts times 57 cells, but I like what it's doing here. We're showing 143 minutes runtime, 73.5 amp hours that have gone into the car. And right now it's saying 4 or 5 amps at 197 volts. Duty cycle of 63.1% and a frequency of 20 kilohertz. Runtime 144 minutes. If you notice, the fan's coming on. Now the interesting thing is our out is showing 9 amps right now, but it's jumping around a bit. And I think you ought to put some sort of integration on there to smooth that out. But as our voltage and current goes up, our fan will kick in, and then as it drops up, charging completed. Man, did we time this right? Disconnect, charging completed, disconnect mains, 73 amp hours in. And so we got down to our 9 amps, and that's exactly what it was showing when it kicked off, even on the input on the Fire Chief. And we were at 197.8 or 198 volts. That's a volt shy of 199. erring on the conservative side by 1 volt. If you recall, our Elcon was, I think, 1.5 volts off. So I'm pretty impressed with the ability of this thing to, number one, it counts the amp hours, and number two, to hit a voltage point and taper the current not only nicely, but to the point where the fan kicks in and out as necessary as it brings down the current. In this fan, I've started jet engines with less forced air than this thing pulls through it. So he's got this cooling itself very well. And so this is pretty impressive. This charger could be used. I'd like to run it several times before I adopted it as a main charger. But the initial take here is that this is hitting a voltage fairly accurately, tapering the charge fairly adroitly, and terminating properly, which is the most important thing. When we talk about BMS fires, BMSs don't magically cause fires. It's typically, they have hooked it up to a charger, and the BMS has turned over this termination function, as we saw in my lab with the little A123 cells. If you don't quit charging at the end, you burn things up. And if the BMS gets lost and doesn't stop the charger, that's it. I would say I would be somewhat suspicious of this one. Multi-controller, home software, if you have a bug and it gets lost. But really it needs the PWM output of that Arduino to run it all. And so if it gets lost, it's probably going to quit. It's not a free-running thing. He's talking about offloading those duties onto another chip. I would not want that. That way the charger could keep running when the Arduino, which is supposed to shut it off, quit. But the way it is right now, if the Arduino gets lost, this doesn't work anyway. And I kind of like that. 2 Arduinos, one monitoring the other one, might even be better. But this is one you can configure. You can program, and it does quite a bit of power. We did 73 amp hours in 144 minutes, which is 20 amp hours an hour. That's pretty good at 190 volts. And this one actually isn't on the highest power setting. It'll do more yet, 10 kilowatts ostensibly. And so for $849 kit, but even at $1,849 assembled, I kind of like the idea. We're going to have to play with this and see if we can do some things with it. I think the software could be improved on that. The current output is very instantaneous right now. I'd like to see a smooth version of that that doesn't jump around quite so much. And maybe a little bit different configuration for us, where we just put in the initial current, the CCCV point, and the termination current. And of course, this is all painful with these buttons, but it works. And if you were building this at home, I would put all this stuff inside the box instead on the outside. This control box is actually on here just with Velcro. And then wired in. Presumably, once it's configured for your car, you probably don't need it at all. And so there's some kind of loose ends on this. He has a power factor correction circuit that is in him now. And I think that's cool. And this Electric Motor Works is working on an Android application and an instrument to be the instrumentation I've been looking for. So I think we're seeing some interesting things from Valery Mitsukov and Electric Motor Works, and I'm quite enthusiastic about this charger. This is quite a bit better than a bad boy, but it's a big boy at 10 kilowatts, and at $1849, that's $3,000 off of similarly sized Manzanita. And so we've got a little bit of a bargain here, and it's configurable, and ultimately it's programmable if you want to go to that level of detail. And so you might take a look at this. It's kind of a interesting box. We're going to play with this some more.
Now that's pretty cool. I mean, you know, we've tried a couple of times with it. It looks like he's starting to get it.
You know, I'm very taken with this for
Yeah.
a couple of reasons. And here's it's not that it's done so well. He's got half the stuff he should have on the inside of the box on the outside. But an open source project is very interesting. And here's why. I don't think anybody can give us the charger of our dreams.
Yeah.
One
probably
is
it's
cost,
yeah.
but two is the liability.
Yeah, if they're always going as the charger overcharging or whatever is causing fires. Yeah, I don't want to be in the charger business.
I don't think anybody's going to want to be in the charger
Yeah,
business.
yeah.
And that's why Delta Q is so
Yeah, they're just selling them to
pansy
who they
dancy
want
every
to.
time we talk to them.
Yeah.
And that's why this has been an issue.
Yeah. Yeah. No, it may be why the people don't want to sell them, and they want to configure them. They don't want to have them, you know, configurable. That may exactly be it.
Well, configurable and programmable gives you the opportunity to really mess something
Yeah, that's
up
right.
good.
To mess something up.
But I like the idea of being, you know, $1,000 in parts and putting it together yourself.
Yeah. I like the heat kit.
And something under $2,000. There'll be people spring up to assemble those for people.
Yeah. Yeah, why not?
And,
Yeah, put
so
another
you'll be
value in
able
the
to
chain.
get a configurable charger for under $2,000 and of some power, 10 kilowatt.
A pretty strong one
This
too.
thing was putting out the current. I needed bigger. We would have tested it more deeply, but I hadn't wired it up with enough.
We
cable.
had those
All
cables
my
were too thick.
wires were getting hot.
Yep, yep.
When you sit there and run it for 2 hours.
But it packed Redux full though in what, a
about 2
couple hours? Yeah,
And it was about halfway down. That's a big battery pack.
Yeah, that's a big pack. Yeah.
It was down 78 or 80 amp hours.
Yep.
And that thing.
It was not
couple hours.
bad. Yep. It ran it up pretty good.
I also found it notable that Jay Leno, his daily driver is a Volt.
That's what I understand. Yeah.
He's had it 11 months, driven it 11,000 miles,
Okay.
1,000 miles a month,
Yeah.
and has never used the gasoline. He's never finished the first tank.
Really?
He's got about a 35-mile daily trip,
Okay. Back
which,
and
by the
forth.
way, that's what
That's
most
what
of
most
us
people
have.
do. Yeah. Yeah.
It's about 35 miles. And now this man has a taste for rolling stock.
Oh,
number
absolutely,
one. He's
yeah.
got to have 100 pieces in his collection,
Yeah, at
including
least.
very early electric.
Uh-huh.
But what he's driving is a Volt.
He's driving his Volt. Okay. Yeah.
And so that's some spin that General Motors can do. That is because people believe more firsthand accounts.
Yeah. Right. What someone's doing. Absolutely.
Of things. So I thought that was interesting. Lee Moorhead in Denton, Texas,
Yes.
left us a little bird on our doorstep at the electric vehicle conversion convention, and I had talked to him about what he ought to do with that, which somehow got turned into what we were going to do for him on that.
What we should do.
And this is a great idea, but it's already turning into a box full of spiders. Let's take a look at our Swallow project. Well, Brain, let's introduce another project. This is going to confound our Elescalade fans.
I know. Oh well.
They think I'm never going to do that car, don't they? What did you and Jeff work out? What did he say about the hydro turbo?
Actually, I talked to him this morning. He has it installed. He has to get a reservoir that it didn't fit the stock master cylinder. Everything's up. He has tested it. He just needs a reservoir. It took a different power steering pump too. It took an extra couple of outlets and inlets to run that thing. It's in, so if he can get the reservoir, that thing will be done maybe tomorrow.
Ah, excellent.
But the brakes are working. He got the test, and he just doesn't have a reservoir.
So we're out of the vacuum pump deal completely. We'll have power steering and power brakes with a power steering pump.
Yes.
But he had to get a different pump with more outlets.
He had to get a different pump with more outlets.
That's
yeah.
okay, because I
Yep.
want to use the stock hoses.
And he's got the stock hoses.
Excellent.
Yeah. Yeah.
So the Elescalade we'll have back with brakes that don't need vacuum
Right.
this week.
Yes.
Excellent. A lot of our viewers are wanting a lower cost solution.
Yeah.
There isn't one.
No, at some point, no.
However, there are some that are lower than $160,000 Elescalades.
Yes, if we start there, and I think we can work our way down quite readily.
I've got some bad news for you when you do a conversion of an electric car. Some people are wondering how much are they worth when you're done.
Oops.
And therein lies the tale.
Yeah.
They're not worth anything.
No, not worth anything more than the car.
Well, they're not even worth that.
That's right.
Here's the problem. You built the car, you know how to fix it. Nobody else does.
No, I had the same problem every time I built a custom car. I actually had to pick the person I sold it to because some people just didn't qualify.
Just, yeah, so when he sold
Yeah.
his Carmen Ghia, which had how many horsepower?
180.
Yeah, in a Carmen Ghia.
Yeah.
He couldn't sell
Yeah,
it.
I took finally a guy whose dad was a Carmen Ghia racer that came out from Ohio.
Right.
Yeah.
Okay,
it
you
took
can
a
have
lot.
my car.
Exactly, that was it. You can have it.
We try to do a little bit of documentation, actually, some diagrams and so forth. And I think as the number of conversion shops grows, and even normal vehicle maintenance facilities are taking an interest in this, that you will be able to get an electric car repaired.
Yeah, I think so at some point.
But we're not quite there
We're
now.
not there, no.
And so time after time, particularly the lead acid guys, they build a pretty nice car. They go through 2 sets of batteries, and they're tired of buying batteries for it, and the new EV Grin is gone.
Right. Yeah.
And so it shows up on eBay.
Yeah.
And what do they go for typically?
Not much.
About half
Yeah.
of the retail value of the original conversion components
Yeah.
is
probably.
what I'm seeing.
Yeah. Yeah. And that makes sense. It's what's the value at that point? But none to them, and maybe something to somebody else, but not much.
Well, on the other hand, if you're looking for an inexpensive strategy, I know our friend Mr. Armstrong up at Gateway EV bought a car that had been previously converted with the concept of putting some lithium batteries in it and kind of getting into the game less expensively that way.
And that makes sense if you already got all the components for half the cost except the batteries.
And so you'll see some bargains on eBay occasionally, and I would say that it's a viable strategy to take a good, and you have to be able to pick out the good from the bad, conversion,
Yes.
and maybe update it with a new charger and some lithium batteries, or maybe a little bit more. Our current project really doesn't fall into that category.
No, this is a little different.
I've fallen in with a guy named Lee Moorhead from Denton, Texas. And Lee's about my age and about my shape. It turns out he was an ET from the Navy.
Oh, really?
Which I almost was an ET. When you join the Navy, they give you a test, and some of us, they wanted to be nuclear ETs. I didn't want to go that far underwater, so I wound up being an AQ. But Lee was an AT in the Navy. And he's about my age, has a daughter, and wants an electric car for her.
Okay.
And he contacted me about this and about what kind of batteries to use and so forth. And I got talked to him about it, and I think he's kind of got a find in a way. So we're doing a really goofy thing. We're not going to save much money at all.
No.
We're going to take a $5,000 existing conversion and spend $15,000 on it.
There you go.
And make a really
See,
cool
look at us.
little EV. I can't help myself.
know,
I
it's
just like the
it
upscale
sounds,
end of the world.
It sounds good, but man, once we put it in the vehicle, it all goes to hell.
When I try to go do something cheap, it winds up not being cheap.
know.
I love to spend money on electric vehicles, and in this case, I'm spending Lee's.
There
And
you
who
go.
knows how to do this
right.
better than you and me,
That's
Brian?
right. Come
So we're
on.
going to get rid of some of
Come
his
on down,
money
Lee.
and make an electric vehicle. Let me tell you a little bit why this captured my imagination. I actually offered to buy it from him originally, and then I kind of offered to do it for him, thinking he wouldn't. You know, it's pretty easy to add some batteries.
Right.
But he showed up with a car
I know.
at the electric vehicle conversion convention and left it with me.
I was surprised it was the only one that didn't go home.
I really like the lines of this little car.
Yeah, it is pretty cool looking.
This was originally done in the mid-90s. He took 2 or 3 years to do it by an architect in Salem, Oregon named Bill Bishoprick.
Okay, okay.
And he wanted to do kind of an updated electric version, but modeled a little bit after the old Jaguar.
Right.
What is it, XJ120?
120, I think, is the one, yeah.
And if you notice, he's kind of got those lines.
Yep.
He called it the Swallow.
Okay.
Do you know why?
No.
In 1922, a man named William Lyons founded the Swallow Sidecar Company to manufacture sidecars for motorcycles.
Really? Okay.
And guess what that grew into?
I don't know.
Jaguar.
Oh, really? Okay.
Or I
okay.
guess in Britain it's a Jaguar.
Yeah, Jaguar.
Jaguar. And he kind of retained the lines to
Yeah,
this.
it's got kind of the 120 lines, yeah.
It
T-car.
originally had 12 Optima Yellow Top lead acid batteries.
Okay, okay.
Of 44 pounds each. That's 528 pounds of lead in your sled.
Wow. That's a lot
But
of
would
lead.
you believe that through the cunning use of foam, fiberglass, and a VW pan from a 68 VW, he managed to do a 1,650-pound car
In lead acid?
that was 528 pounds of battery.
That's not bad. That's pretty good.
Lightly as goodly.
Yeah.
Aerodynamically as goodly, too.
Yeah.
And I think this
Got
one
nice
probably
lines.
has it. He originally had a range of 30 miles an hour and did the quarter mile in a little over 20 seconds at 65 miles an
Okay,
hour.
okay.
But he estimated top speed at 95. And it was a good little build, sufficient enough to be featured in the October 1998 issue of Kit Car Illustrated magazine.
Okay, okay. All right.
And Lee picked this thing up for about $5,000, was going to put some Calb 180s in it. And in fact, I've ordered 40 Calbs 180s, and we have them.
We have them, yeah.
How come all these projects wind up costing me more than the guy we're doing them for? Brian cleaned out the battery compartment, and what say you?
I don't think that the Calbs, I mean, I don't know if we could squeeze them in there properly, those Calbs in the front of this vehicle. And then we have to start moving them in the back of the car. This is a light car already. And, you know.
We weighed it. What did it come in at?
What was it, 11 something?
1125.
1125. That's a nice start.
That is a nice start, isn't it?
Yeah, that's a
with
really
a body on it, a windshield, the motor, the transmission.
Yeah, really just batteries out and some few miscellaneous
At
pieces.
1125, we're kind of getting breathy on weight.
Yeah, that's a light vehicle. And you know what, we were looking at, what did we weigh? Figured out the batteries, the 180s would be, what, 500 and some pounds?
443 pounds without
443.
the boxes and the straps and the bolts and so forth.
Yeah.
So probably 460 or 470 pounds,
Yeah.
which would be lighter than the original 525 pounds of lead.
Right.
And my God, a 36 cell pack, 180s.
Yeah,
This would be 24 kilowatt hours.
yeah.
Well, this car would go 200 miles.
Yeah, that's a lot of range in this car. You got to want to go 200 miles pretty bad in this car. So light,
Calb 100s would be 253 pounds. They're 7 pounds a cell.
see, now that makes a lot more sense. The 100s.
And Brain mapped out a way to make 36 of these Calb 100s fit into this engine compartment
Fit into the front, yeah.
straight up.
Yeah, straight up, one box on each side. And in fact, we have a little less weight on the driver's side. So we'll put a driver in. Now we're probably going to look, we should have a pretty good weight distribution. And, this car should be fun to drive. It should handle nice. It shouldn't be flabby.
So how many cells are on which side of the tunnel?
We've got 23 on the passenger side and 13 on the driver's side.
Excellent. 13 times 7 is
13 times 7 would be
91
106.
pounds?
Yeah, 13 times 7, 90, yeah, 91, yeah.
so with a driver, this kind of
It kinda
balances the car out.
Yeah, we'd have about 70 pounds less on the driver's side without the driver in the car. And that's, I think, what they do, the OEMs do when they set up cars. You can put a little extra weight on the
And it was
passenger
kind of 700 pounds rear, 400 front. And this would get us to 700 and 650
side. Yeah, we
front.
almost 50-50.
That wouldn't be bad, would it?
No, this thing should handle nice.
Well, we've kind of made a command level decision, Lee, that what you're going to get
That's right.
is a set of 100s. I'll find something to do with the 180s.
Yeah, yeah.
And we found enough other ways to spend your money that it's still going to cost 50
That's
grand.
right. It'll still going to work out.
Talk to Bill Ritchie at
Yeah, HP EVS, yeah.
High Performance Electric Vehicle Systems. They've become kind of, they like to talk to us after EVCon.
Yeah, they are. They've
And we
They're
have
players.
discussed with him at some length the 818 project,
yes, we have.
which we haven't even got Dave Smith on board yet.
No, but they know my name now. We're getting better.
What Bill was talking about was a water-cooled 9-inch new motor
Yep.
with the Curtis 145 volt
Yes.
new controller. A chill plate for
Yeah.
the Curtis that they're going to do. If you recall, we engineered a chill plate. They think they can do better and much simpler. I do too. What I sent over and what Igor and Brain come back with was a mess. Worked very effectively,
It didn't leak.
but it was just too heroic.
Yeah.
All we need is a channel and an aluminum plate and a rubber gasket.
Like an O-ring, yeah.
And we can bolt it right to the bottom of the Curtis.
Yeah.
And that's what they're doing at
Yeah.
HP EVS. So
Okay.
they'll have a nice chill plate for this 145.
Cool.
Plus a water-cooled 9-inch motor that I'm told will put out
Okay.
150 foot-pounds of torque with this Curtis.
Was that the controller?
And so we're going to do that for the 818.
Uh-huh.
That would probably flip this car.
Yeah, it would be a lot.
In fact, I'm a little uneasy over what we're doing, but it'll be cool anyway.
I think we'll have a nice chassis with that car. So.
Lee, we're going to put in the 650 amp Curtis with the AC 50.
Yeah, that's a
And
nice combo.
that's going to, this vehicle currently has a little 8-inch EDC, which moved it fine at 1,650 pounds.
Yeah.
And now we're going to put in what we've got in the Spider, a 650 amp Curtis 1238 7601.
Right.
And the AC 50. And Brian, 250 pounds of calves
Yeah, 250
and
pounds.
1125 is 1,400 pounds.
Yeah, that's going to be great. This thing will be pretty cool. This one we may not want to give to him.
Now, with the bigger motor, we're going to have a little bit bigger controller. This had a Curtis 1231 in it. We weighed it without the interior.
Right, and that wasn't much though.
Yeah.
The interior wasn't a whole lot.
But I still think we're going to come in about 1,500 pounds is the budget.
Yeah, that's not bad.
We're going to have a 1,500 pound vehicle with 12 kilowatts.
Yes, yeah. 12
kilowatt hours
Yeah, 12
of
kilowatt
battery
hours, yeah,
pack.
Yeah.
and I'm claiming he's going to come close to 100-mile range anyway.
That's what I'm thinking. With the aerodynamics, I think, of this car and some,
Aerodynamics, a 16-year-old daughter.
yeah. We'll probably, what do you think? We can get some low rolling resistance tires on here?
That's an interesting topic, Bree.
Really?
Guess what this car originally had when Bill Bishop built it?
Probably not these Toyos. These are a little
These
later
are Toyo
model.
low profiles. They're kind
Yeah.
of cute.
Yeah, the Proxys.
No, we're going to go back to some Bridgestone Ecopias for Lee.
Okay. Okay.
And that's what the car originally had on it. He had
Really?
some of the earliest Bridgestone Ecopia low rolling resistance tires built.
Really? I didn't
on
even know
this
they made them
car
that
in the 90s.
that long ago.
I
Wow.
didn't either.
Wow. And we already ordered the set there. Be here in a couple
Some
days.
other interesting facts. This is actually a windshield out of a Datsun B210 that he did the body around.
Okay.
It's painted 1997 Ford Probe Boysenberry metallic.
Ford. I guess this does look familiar now that you're saying that, this paint color.
It was a
Wow.
98 article.
Okay.
I'm saying he got it painted then in 97. He worked on it 3 years, 94 to 97. And so that's the era of this car. And that's the paint in case we need to match it.
Okay.
I suspect that AC50 is going to poke out the back. And so we need a little bustle for the back of the car somehow.
Bustle for its.
But Lee said
rear end.
he can work on that. He's thinking about painting it or doing something with the fiberglass anyway.
Okay.
So I think we put on a set of Bridgestone Ecopias.
Okay.
Let's do the brake transducer trick for the regenerative
yeah, we know
braking.
that works good with that Curtis. Yeah.
He has a, what do you call the clutch?
Oh, he's got a hydraulic clutch. Yeah. It well, we started tearing through some of the mechanical stuff now while we're waiting for the other parts to come, because we wanted to make sure they had a clutch. I still don't know about the brakes. I'm going to suck this thing dry and see what we've got. But the clutch,
They're disc
one-
front and drum rear.
yeah, disc front, drum rear. Yeah.
Let's stay with that.
Yeah, I think that's
If
a
they
good
work.
setup for this. Yeah, and if they don't work,
Put a
the worst
seal
thing
kit
is
on
some
the drums and
exactly.
some new shoes.
Yeah,
put some pads on the front.
Yeah,
I
it
think
shouldn't.
you'd be
That
right.
shouldn't be. That should not be bad. I mean, this is all VW equipment. So
But let's get that hydraulic clutch upgraded and updated. It was kind of shot, wasn't it?
yeah, the master cylinder the plunger was completely frozen at the far point. I mean, it just flopped
Mm-hmm.
around. So that's already been ordered. In fact.
I happen to have a 4-kilowatt Elcon set up for 126 volt charging.
That's right. We did get that. The two Elcons, and we
Now,
didn't use
it's
one.
kind of heavy for this vehicle, but if I threw that in the front on top of your batteries, this thing would charge in about 2 hours.
Yeah, that would be amazing. I mean, that'd be so cool.
So we'll upgrade it with J1772 from Dave Kurzel's modular EV power, so
Okay.
it'll work off of public charging.
Public charging, cool.
Probably put in one of our little NEMA 515. What are those, Marinco?
Oh yeah, the Marinco, just so he's got an option if he needs to plug in when there's not a J1772.
And the brake transducer. Let's throw in a low car, a Hall effect pedal. This has kind of a crusty old 5K pot
Yeah, it's just got
assembly.
the cot.
I think it'll feel better with that little low car in there hooked into the Curtis.
Yeah, I think so too. And this is the stock VW pedal. It's cable operated. It's just okay.
And maybe get him a little interior work done with some of that Tempur-Pedic type of memory foam
Yeah,
stuff.
kind of a real high density
You can't
foam.
really get in this car. What they've done is put the seat over the rear seat of the Volkswagen.
Yeah. You would be sitting up here, really, somewhere around in this
On the
area is where
pan.
your seats would be in a pan. They've moved this whole thing forward in this T-body style, and so you're really sitting back here over where the rear seats were, over the shift coupler.
And he's got a little roll bar here that I just find annoying and want to make go away. And Lee's kind of signed up to that.
Oh, okay.
That he
All
didn't
right.
need it or want it either.
I think
And,
it'll just make the car feel a little bit bigger, especially on the driver's side.
Yeah.
And if we may be able to engineer some seats that'll, maybe give you a little higher, head portion too, a little, almost a headrest. Okay, that's fine.
Well, I'm hoping to make it where I could test drive it, and Lee could too. Before turning it loose with his daughter. I might, it's got seat belts. I might suggest a 5-point.
Yeah, we're gonna have to re-engineer
if you could
something.
find something like that, that's a little bit more,
Yeah.
uptown for a light vehicle like this.
Yeah, we'll
I
do it
think
like
that'd
what was
be-
in the Spider.
Yeah, like in
same
the
thing.
Spider.
Yeah, we'll throw some Sparkos, some Schroths in there or something. Be nice. Yep.
So Lee, I think we can get rid of your 15 grand pretty handily.
Yeah, any more if you got it.
Even with a 100 amp. But I think we can update the drivetrain,
Yeah, I think so.
the charger we have to,
Yeah.
the batteries, keep it light.
I think that's the way to go with this car. I think quality over quantity, light. Yeah, I think this would be a nice little car. It should handle great.
If Rain made a command level decision to remove the body so we could examine the chassis, and I like all that.
Jack's never seen a Volkswagen naked.
Right, this is my first time with a fully undressed,
How was it?
matronly
That's
Volkswagen.
why you wanted a cigarette. It's like, okay, I got it.
Yeah, it's good for me.
An unclothed Volkswagen.
So, our Volkswagen Pan, it looks a little rusty, but we put some black paint on it and stuff. Is that going to make it?
Yeah, I think it's going to be okay. The one spot which is now under the passenger seat, because everything's been moved back in the car, where the battery usually sits, had a little bit of rust, but they had already welded in a plate there, so that's fine. But we did find some other issues with the car.
We had a hydraulic clutch. How quaint. Tell me about that.
Well, see, in this car, what they did is usually up here is where your pedals are. And as you can see, they moved them all the way back to this point, which is really the front of the seat bracket. So here's where the body is. So they moved the pedals back, 2.5 feet. So normally your clutch is by a cable that's running through the tube all the way to the back of the transmission. You really can't do that with this setup. So they did a hydraulic clutch, and there's nothing wrong with a hydraulic clutch. A lot of guys do them that build dune buggies, things like that. The problem with this one is
There's something wrong with the hydraulic
that the master cylinder, the plunger is stuck inside here, probably right about here. So it wasn't drawing back at all after I bled it. So
15-year-old build, I guess we'll have to get another one of those.
yeah, we've got that on order. We also got the slave cylinder on the back. This is not the way to attach them. This is where your Bowden tube, where your clutch cable usually goes, this little bracket on the transmission. And what it does is when this thing expands, it loads it against this, so it kind of flexes. These will wear out anyway. They tend to get a little oblong inside. So this may or may not be any good, and if it is good, it probably won't be good for long. So I also got the proper bracket that will hold this in tight. Using this Bowden tube bracket is not the thing to do with a hydraulic clutch.
Lee, we're trying to find some pieces we can reuse.
Yeah, but hopefully you don't hate us for this segment.
The
but you're-
spring on the clutch and throw-out bearing is very stiff. I think that one we can still keep.
Yeah, I don't think we need to replace that. Yeah.
So here's where your clutch, your slave, hydraulic slave goes.
Right.
And that, I guess, goes that
It
direction.
operates our throw-out bearing.
Uh-huh.
And we'll go ahead and replace that. That's a $10 part.
Clutch looks pretty good.
Yeah, the disc is not bad. Doesn't look burned.
Well, clutch and throw-out.
Yep. And this has actually been balanced. It's got a little piece of metal welded on here. So this has been balanced to the flywheel. They did lighten the flywheel, like we did for before we built Redux. First time we did it. So it's been balanced, and it's probably not weighing much. It's
So
probably
they
like
took
that,
that down quite a bit, huh?
just like we did on our original build. Yeah.
This was the hub that was on the motor.
Yes, that was the hub, the coupler. Yeah, it's a very, very nice fit on the shaft, and we had to press it off. We got it off.
Well,
We'll
it's
try
got a
it.
key and some little set screws. Is that going to work?
We'll try, I guess, and look at the motor. I mean, if we can't use this, then what we've got to do is use a different adapter plate, which the nice thing about this adapter is they had a 1/2 inch aluminum piece. They had 2 different sets of holes on it, and these out on the outside are actually for the 9-inch motor. This ring is for the ADC. It's too small. If we can use the coupler, we may be able to use this adapter plate and just have a ring made, which would be good because we don't want to have too big of a ring and be pushing this motor too far out toward the body if we can help it when we put the new motor in. So if we can use a ring like this, that would be all we would have to purchase at least. We'd be good with the flywheel, we'd be good with the clutch assembly is balanced, the hub.
We had actually entertained the idea of keeping the ADC 8-inch motor and Curtis 1231 if they worked well.
Yeah.
What did you find?
Well, what we found, since there was no tail shaft on that ADC motor, we never spun it. So today...
No batteries.
No batteries. So today when we got it off, it only turns in both directions about, I don't know, maybe 40 degrees or so. It's
So the motor's bound up.
the motor's bound up, yeah. I don't know what. It could be something just mechanical inside. It could be stuck, a brush or something. But right now, no, it couldn't have. We would have found out.
So bad motor, Lee, or you didn't lose anything there upgrading.
No, it'll be looking good with a nice new motor.
So this thing was maybe not exactly in the shape that he was thought he was getting.
No, I mean, and we found too yesterday before we took the body off that the front part of the body wasn't bolted down.
Right.
There was only
Wasn't bolted to the chassis.
there was only really 2 very thin, aluminum angles that were holding it down. Nothing in the front and nothing in the rear. So it was. Oh yeah, the Swallow project.
You're the VW guy, Brain.
Yeah,
You're
it's,
going to have to paddle us out of this.
I know, because we do have.
all little mechanical things.
We've got mechanical
and it's all
VW stuff.
stuff. And
Yeah, we got a 40-year-old pan
it's
that we're working with.
circa 1968. And this is exactly the kind of car I told you I never want to be involved with, is a restoration on an old rusty bucket. And here we are.
Here we are. Yeah, well, at least it's a VW. It'll be, we'll get it nailed down. I just have never seen that brake in the back. That shock tower, I guess it's the body being gone and really no rigidity that allowed it to flex so much and snap it, but I've never seen that. So if anybody knows how to fix that, let me know. You guys out there, send me an email.
We have been talking about the battery vendors. Now I have to go back to Calb and get 100 amp hour cells.
Instead of the 180s, yeah.
I had asked if any of our viewers had actually received batteries from Simon.
Yeah, I remember a couple episodes ago, yeah.
Not a peep.
Nothing. Huh.
And Winston is now exclusively selling through Balcon.
Balcon.
They're quoting 60 days for a battery.
And they've got a facility here in the United States.
Well, yeah, but they've got all the big batteries for the trucks. Anything that we would use, it's 60 days.
Oh, no.
And so I'm not sure what's happening with Winston, too. We may be down to a single source. Now, I have managed to get some of the A123s.
Yeah, some of these, yeah.
At $30 a piece. By the time you pay shipping and PayPal, the guy does take PayPal, though.
Oh, really? Okay.
And then, of course, after you cook them, they're
they're a little more expensive as you deplete your supply.
But about $36 on my floor.
Yeah.
But $30, and they're quoting me $23.80 in quantity. I am working on a module, and I hope to have it to show next week. However, there's not really a point unless these things get really cheap.
Oh, by the time you put the module together and all that, yeah.
I think my module's going to be larger for a 100 amp hour cell than the Calb 100 amp hour cell.
Oh, man.
It could very well be a heavier. The 485 grams has got to be 495 grams in the A123s.
Oh, okay.
They're not quite in typical American fashion. They're just under 20 amp hours instead of over.
Instead of just over, huh?
Yeah.
Okay.
You might have one cell hit 20 amp hours somewhere. But by the time I get them put together, they're going to be bigger volumetrically
Oh,
than
man.
the cells we use.
Ouch.
Probably weigh about the same.
Okay.
And the only and I think, well, they're going to cost more because you have to build the module. Although I'm working on a very low cost way to do that, but it's still going to be more expensive. However, the one application would be if they'll put out 20C, and they're
Yeah.
claiming 60C.
Okay.
But if they'll put out 20 times the rated power, you could build a 100 amp hour pack and get 2,000 amps out of it.
Yeah, so it would drive nice.
Well, it would.
Drive the motor nice.
It's kind of going the other direction, but it gives you an option
Yeah.
to do a, well, like a dragster.
Right.
A lighter weight car that's higher performance, albeit shorter range.
Right. Yeah, just
You
less
remember
range.
the original Speedster we did had 2 strings of 90
Of the
amp
90
hours.
amp hours, yeah.
But one string wouldn't really get the maximum out of the
Right.
motor and the controller.
Right.
Well, one string of
These-
these at 100 amp hours would.
They would do it. Yeah, this would do
And
it.
so you would need a second string. Now you're sitting there with a 50-mile car instead of a
that's
100-mile car. Maybe a little bonus because you're lighter. So a 55-mile
Yeah,
car. But reality zone, Leno's driving 35 miles.
Yeah, he's driving 35 miles.
But if you stepped on it, you could get 2,000 amps. Now that's the only advantage I can see with these 1, 2, 3 cells.
Okay.
And
yeah.
you have to assemble them into a pack. But I think their availability is going to come along pretty good.
Okay, good.
And the reason, the heart of this, I have to believe, is Fisker.
Oh, okay.
Fisker is claiming 20 miles per gallon in gasoline mode.
Okay.
And they have variously been rated from 32 to 51, I think, miles of electric. The EPA rates them at 32. So California won't even let them in the, what do you call it, the HOV lane,
HOV
the hover lane?
Right, yeah,
Is
the
that-
HOV.
Is that where hovercraft goes?
That's where they go.
The,
Right
the
on
carpool lane, what does HOV stand for?
High occupancy vehicle.
High occupancy vehicle. Electric cars, most of them, including the Volt, has been certified for this now.
Okay.
Qualifying California for single occupant HOV use.
Okay.
The Fisker will not.
Because it's not high enough in economy.
Now, they claim they've had some problems, a flood, a bad shipment of leather, for example. And so they're a little slow out the gate getting the cars going, but it's jamming A123 up. Remember, they told us a year ago that if they did want to sell to people like us,
Right.
they couldn't because all their production was gearing up for this huge thing with a famous OEM.
Famous
which was
OEM.
Fisker.
Yeah.
Well, Fisker is not very famous. They're about to be famous for having the dumbest green car on the planet at $95,000 and 20 miles a gallon, spewing CO2 in all directions.
Yeah.
This
And
is
now-
not
yeah.
going to be the darling of the green crowd.
No.
The Fisker is not going to be the car.
No.
And since it's not
There's
even
nothing to
all
do.
electric, and
Yeah.
it's $95,000, I'll go out on a limb and proclaim this car DOA.
Okay.
It's not going to make it till the end of 2012. Nobody's going to buy this car. It's beautiful.
It's a beautiful car. It just doesn't make a lot
It's
of sense.
$95,000, but none of it makes a lick of sense.
No, it doesn't make a lot of sense. Yeah.
And nobody's going to buy it. The people who are environmentally conscious are not going to go for this. It's $95,000. It doesn't have enough gadgets. The Model S is going to be here at the same time almost, It's
Right,
going to be here
close enough,
mid-2012. It's November 2011. Fisker's shipping 2 or 3 cars a week and giving them to Leonardo DiCaprio and any movie star that can get to take it. But it's DOA.
Yeah, it doesn't make a lot of sense.
And it could potentially put A123 out of business. Interdel being delisted from the NASDAQ,
Oh, it was.
Yeah, they're gone.
Oh, that's the end of that.
And
So
Interdel had a similar deal with an investment in Think City.
Yeah.
And they're not completely out of business, but they've been delisted on the stock exchange, and that's usually the last whimper.
Yeah, that's pretty bad.
And A123 has a deal going with Chevy and the Spark, but it's out there. And meanwhile, they're piling up inventory of these cells and no place to go because Fisker doesn't need them.
Fisker, yeah.
And I don't think Fisker's ever going to need them.
Yeah, that's a heck of a, that's a heck of a price for that type of car. I mean, for that performance.
So we may have Brazilians, these
laying
A123
around.
coming from Korea through China to Missouri because in Framingham, Massachusetts, they won't sell me any because they want to deal with OEMs and Fisker. Okay. I hate to crow, but there's a dawning awareness, and the world is coming around to my point of view on this, that it's going to be a little bit of a work to convert the planet to electric drive for personal mobility.
Yes.
And it's going to have to be a grassroots movement. We welcome a Chevrolet and the Volt and the Spark and Fisker and A123 and all these guys, but they're romancing the stone of we're going to start at the top and work our way down by making a Brazilian of them at General Motors and Nissan, and everybody's going to sell the OEMs, and we're all going to hold hands, sing Kumbaya, and it's over, is not going to happen. And it's our people, the ones that have been building their own electric cars and still do and still enjoy it,
Right.
Who are also going to be the low-hanging fruit I've spoken of, that buy the Leafs and the Volts.
Yeah, the
Teslas.
Our guys want them, yeah.
And that demonstrate these to ordinary humanoids a one-on-one, and are the flag wavers and are the apostles that are going to carry this message to the world. Now, if you don't get with these guys, you're not going to make the trip.
Yeah, it's going to be difficult because
Even with a really sexy $95,000 stupid car.
Yeah.
It's not going to happen.
not going to happen. Yeah.
And
it's
so
it's
they
just
can
not there.
they can come get right with Fred Baining and Tim Cavalier,
right. Come
and
hang out with the guys.
Christopher Fisher, and hang out with the guys, or they're not going to make it unless you want to come in 8 years from now.
Yeah, right. That'd be a different story. Yeah, it's just too early for what they're proposing.
We're just too early in the game.
Just too early.
The
That'd be
Chinese
great.
government is rattling the sword. They're after all the cities to do the waive the lotteries and license fees and everything. And BYD's stock went up this week.
Oh, I didn't see it. Okay.
Just on that. Tesla's stock hit $35 this
Oh, really?
week. Yeah, there's some stuff
There's
going
things
on.
going on out there, yeah, some rumblings.
But it's simply an increasing awareness that this is a solution and should be the solution. Although there are others. Guess what was named the Green Car of the Year?
Not the Honda.
It was the Honda
It was, okay.
natural gas car.
Yeah, the natural gas, okay.
That's pretty good.
Yeah.
You just guessed that.
I did. I couldn't remember, but in the LA auto shows this week, we'll probably get some stuff out of there too.
I like natural gas. I want you to run it through a power plant and send it to me in the form of electricity.
Squeeze it down a wire.
I'm all over T-Boone Pickens, but just run it through a generator and send it to
That's
me.
right, just squeeze it down a wire, guys.
I like natural gas. I don't like tanks and compressors and that.
Yeah.
And, so I really and a whole natural gas infrastructure. Of course,
Ooh,
most
yeah.
people have natural gas in their home. There is a company in Canada that will sell you a home compressor.
Oh, to compress
but
the-
it takes all night to compress the 4-pound natural gas into your house,
Yeah.
into the 2,000-pound natural gas in your car, that
Yeah.
to have 150 or 200-mile range.
Yeah.
Well,
And
duh.
and how much electricity does that take?
Yeah, right. And it takes a bunch of electricity. Why don't we again just jump to the chase? Just give me the electricity and I'll drive on that.
That's right. We'll stuff it in some batteries.
And if you want to make electricity from natural gas, God love you. I think that's a good idea.
That's actually a good idea.
I'm not so green, and I'm totally. Natural gas is a lot cleaner than
Yep.
coal and oil
Yeah.
and gasoline.
Yep. And there's a lot of it out there.
And you can make some very efficient, and I don't think all the environmentalists are really familiar with the technology there, but there are some very interesting turbine devices by General Electric that run on natural gas that are quite efficient at making electricity out of natural gas and quite clean burning.
Yeah, very clean. Yeah, natural gas, real clean.
So there's a lot has been done there, and a lot can be done there that shouldn't be overlooked simply because it's a fossil fuel.
Yeah, right.
We are
right.
shaping up as the Saudi Arabia of natural gas.
Yeah. Yeah. It's
Exxon,
light and clean.
not
yeah.
Exxon, but XOM, the stock symbol. I used to trade in a little bit. Actually got themselves in a financial bind because they found so much natural gas they devalued their holdings.
The price went down.
And had to sell them
Through the floor.
It really may be dangerous to your health to smoke in the United States because one butt down the wrong hole, the whole continent may go.
That's right. And usually it's under like hard rock.
And
It'd be a
it's
heck of a
yeah,
mess.
well, it is,
It'd be
but
an
it's
awful mess.
it's not even all. Everyone is dismissing this as being fracking and so forth. No, there's just a lot.
There's a
of
lot of
natural
it.
gas.
Yeah, there's a lot of it around. Yeah.
And there's still these guys drilling wells are just flaring this stuff off.
Yeah, because what do you do with it?
What do you do with it? In
Yeah,
North
and it's so cheap. Yeah.
And people don't realize that's going
It's
on.
better to
They're
just light it on fire.
Burning plumes of it
Yep.
off into the atmosphere because it's.
Yeah.
So there's that. Let's reconvene next week, see what we got going with the Elescalade.
Okay.
We'll continue with the Swallow.
Yes. See if we can get some.
Remind me, I
movement.
have to get one of those 24-volt kilovacs to run that Curtis.
Oh, that's right. We need 20. That's
And,
right. We do need that. Yep.
And we'll get that Swallow perked up in pretty short order. I kind of like this working on the chassis separately from the body.
Yeah, I mean, it makes life a lot
Maybe
easier.
we've been missing a trick.
Yeah, we'll just have to get cars that are not wired.
No, not really. We need to work on them as cars because same old problem maintenance.
Yeah,
You don't want to put anything on you can't get back
can't get
on.
to. Yeah, exactly.
And it's too easy on the chassis.
Stuff
and
something on the chassis.
Then you put the
Then-
body on
then
and
go,
you can't get
what
it
happened
off
to that
at
thing?
all.
That's right. Where did we put that?
What's that? We don't want to pull the body to change a motor. or
Yeah, there
something,
you go.
That's not gonna go. So, anyway, stay with us. We're having a lot of fun. Neat new projects, electric drive, and kind of an exciting future.
Yeah, it's great.
So come back and see us next week. We'll try to have some more fun stuff with Jack and Brain.
We'll see you.
Yep.